All right. So over the past few days, we've been assigned a number of exercises. And for some people, that might be too many exercises. For some people, that might be just enough exercises. Starting today, we're going to be doing all our challenges in two languages, in Python and JavaScript. And the idea here of why we're doing Python and JavaScript at the exact same time is that we don't want you to get to your job and be scared to learn something new. By learning two languages at the same time, we're starting you off right at the beginning of your software engineering journey to, be able to learn new things quickly. For me personally, this was a point of contention because I only did Ruby. I learned Ruby at my bootcamp, and I did Ruby until this past job. Like until then, I was just doing Ruby development. So I was like, why do I need to learn anything else? And then I realized that nobody programs in Ruby anymore. Or if they do, it's like it's just maintenance at this particular point. So I don't want that to happen to you. We're going to be learning two different things at the exact same time. All right, it is Thursday the 7th, which means yesterday. Let's see, what is interesting? Linear search seems interesting, and we'll do also one on factorial. So the thing that I'm doing right now is I'm going to be simulating more or less what a senior engineer is going to do. So I'm looking at linear search. There are 12 pull requests here on GitHub. And just a quick refresher, Git and GitHub are not the exact same thing. Git is version control software, meaning that it keeps track of different versions of particular software. GitHub is just a place where Git repositories are stored. GitHub is popular because they were the first company to take advantage of the name Git in their company name. But there's other ones as well. There's GitLab, which is another company. There's another one called Bitbucket. And these are all places online. These are companies online that you can store your Git repositories. So you can store, it's basically an online Dropbox for code. Another one is GitLab that we can use if we wanted to. Another one's Bitbucket, but most people use GitHub. We'll talk about the commands a little bit later when we actually start coding, but let's take a look at these pull requests. Pull requests are basically requests from other people saying that I've made changes to the code that you've already put up on GitHub, and these changes I think are good enough to be put into master. Master is a branch, so you can kind of think of it as, imagine you are working on the newest Star Wars film, and let's say that you store it on GitHub, and it's like Lucasfilms is the organization, and the name of the repo, the name of the folder that you put on GitHub is Star Wars, is it 10? It's 10, right? Yeah, Star Wars 10, the next one, because the last one was horrible. At this particular point, you'll notice that we're on a branch called master. And what this means is like, this is the master branch. This is like the most up-to-date, what George Lucas says, this is what we're working on. This is, I've only worked the first act, but this is master. This is what's going to go inside the movie. What's happening here is that all of Lucasfilms' like interns are saying, I have all these different things that I think could go inside the movie. So I've made some changes to the original code base, and I think that we should push this inside of the actual code base. So I'm going to choose somebody at random. I'm not doing Tom. I don't know who West Computing is, but I'm going to grab this person here. All right, so this looks like it's, I have the name, but I forgot. Sorry. Okay, all right, so let's take a look at this. So West Computing opened a pull request from his forked version over to this master branch. He's made 51 changes, 51 additions, and 1 takeaway. So let's take a look at what the files that he changed were, and let's kind of tear it apart. All right, so I'm looking at factorial, and we said that factorial was, all right, so I take a number, and I multiply that number all the way down to 1 and all the numbers in between. So I get 4 times 3 times 2 times 1 gives me 24. The factorial of 3 is 6 because that's 3 times 2 times 1. So let's take a look at this person's solution. All right, so it looks like exports factorial, function number, okay, return, okay, here's a ternary operator I'm seeing here. If the number is less than 2, then return 1. Otherwise, do 1 times exports factorial. So you're doing a recursive solution. That's fine. So one thing I will say is that it depends on who you talk to. Most people try to write code that's readable before it's optimized for performance and like the number of lines of code. This is a totally legitimate solution. I don't think I'd change too much about it if I was like, if we're talking at like a more senior level, but I'm gonna write a little something here. It says like, we want to write code that is and then at this point, I'm going to hit start a review. The people writing this generally won't write full sentences like I just did because they are very busy senior engineers. So the way that they approach this is that they're just going to start like writing like really blunt comments. So don't get offended when people go through your code base to just have really, really blunt comments. Totally fine. I would avoid ternary operators personally, but it is a legitimate solution. All right, so we have a function called find max factorial that's not used outside of this thing. Okay, let test equal 46 while exports test to your plusing the two. Okay, so you're okay. While you start at 46 and go up and go towards infinity, return test is too big. So you're basically saying that as long as it's less than 46, you can compute it. Otherwise, it's too big. Okay, console log test. Remove all console logs before pushing. Return test is too big, and we're using the interpolation here. Require main as module, console, that's fine. Okay. We're gonna move away from using driver code, which is what this is right here, and we're gonna do test-driven development today. And let's take a look at the factorial here. Same thing. Readability is more important, and one-liners. Let's see. For f in range 2 to num plus 1, result times equal f. All right, so let's say I start, the result is 1, I'm returning the result, so anything times 1 is 1. For f in range, what is f? What is f? I would name this as a number in range for something more descriptive. So I'm just trying to read, what I'm doing is I'm reading through this, I'm trying to nitpick every little small thing and just saying like, what are things that can improve here? So we're taking in a num, which is fine. That's the starting number that we have here. But then we have f. I was like, what is f? F is not terribly descriptive in any way. It's not like something like K or V when we're iterating over a dictionary, which stands for key and value, which is just the first letter. F doesn't really mean too much to me, but I know that what he meant here was it's a number in a range. We're starting at 2 and we're going to the number plus 1 because the way that range works is we have to take the ending number plus 1 and then we get the actual ending number that we want. And then result times equal f, return result. I like this, it's good. The only thing I'd change here is that this f doesn't mean anything to me.
Hey, John, can I ask a question about that?
Go ahead.
Is that true also for things like it's pretty standard to use I when you're looping through something, or J or K?
Yep.
That's okay.
So I would say I, K, and V are totally are fine. I stands for index 9.9 times out of 10. K stands for key and V stands for value. J is fine. I've seen that when you have two loops within each other. But other than that, I personally like to have it so that there's no doubt in my mind of what I'm dealing with. Because if somebody else is coming in and they're like, and it's a year from now, and this person has left the company, they might be like, I don't know what F really means here. Obviously, this is a pretty simple algorithm, but It's kind of like, what am I supposed to be, what is F? But if you know it's like, it's a number in range, like it's the specific number that you're talking about, then you know immediately, okay, that's what this particular thing means. So you want to have descriptive variable names with that whenever possible. All right, I'm going to ignore the rest of this, so not bad. I'm going to go ahead and just say like, looks good to me. I'm just gonna submit this review here. And now this person has some feedback about how to improve their code. Let's see how we're doing. I have 9 minutes before I lose everyone's attention. So let's go over to linear search. I'm going to take Eric Murphy. Okay. All right, so let's take a look at linear search. So this is the finding a needle inside of a haystack. Basically, I am looking for, if I give you a needle, like the A, and I give you something to look through, find me either the first instance where it shows up or all the instances where it shows up. All right, so let's take a look. So Eric and Steve opened a pull request. They've made some changes in 2 different files, 23 additions and 8 removals. All right, let me take a look here. So it's only in JavaScript. Okay, so we're gonna start on line 6. Exports basic linear search and global linear search. I like that's descriptive. Value defined, array to search through. Cool, we notice that these are all camel cased, meaning that every single new word is capital after the first one because of the humps of a camel. For let I equal 0, in this case it's okay to use I because it's super popular. I stands for index. I is less than the search through dot length. I plus plus, you are missing a space right here. Start a review. And you might think this is super nitpicking, but these things are the things that people are looking for on like an actual code review challenge. So you're missing a space there, that's fine. If value defined is equal.
Are we gonna ever talk about where exactly spaces should be? Because I'm always confused, like when there's like additions or subtractions, multiplications, where spaces should be and stuff like that.
Yeah, I haven't actually really never thought of like exactly where things are. I just kind of keep writing code until it works. And then when someone criticizes me enough about something, that's the particular point that I change. Okay. So I think it's a legitimate question. I whenever possible, like let's put it this way, I try to write syntactically perfect code as much as possible. And then I will criticize whenever there's something wrong. So hopefully that will be sufficient. Let's take a look here. So basic linear search is just the very first time that I see something. So if the value defined, the thing that I'm looking for, is equal to the element at that particular index in the array, return I, and we're done. Cool. Otherwise, you're going to return undefined. That's okay. You can return -1. Otherwise, this is fine. All right, global linear search is a little bit different. If I'm looking for a particular letter, and if I take the word bananas and I split it each individual letter, I want to find every single A, which is at index 1, 3, and 5. Notice there's a chat. Let me take a look at it. Shift. I would be again, it's one of those things. Okay, so it's Julie plus. I got that. Okay, so one thing I would be very careful of is all the built-in magic things that VS Code gives you, because in an interview, you might not have VS Code. I had an interview with Google where they literally said, open up a Google Doc and start typing code in there. There's no help for me in there whatsoever. And I think that they did that on purpose. Actually, knowing Google, they do that on purpose because there's no way for me to get any sort of help. I can't do Shift Option F to format anything. It's good if you're just like, if you want to get it done really fast. But again, it's one of those things where I'm taking shortcuts, which are totally legitimate once I'm on the job, but I don't want to train for once I'm on the job. I want to train to get the job, and then I can use whatever tools that I want. So totally legitimate.
Well, I also thought that we were going to start the 8:45 next week for some reason, and I was like,
That's
I got on at 8:30, and I was like,
going to mute Rod. Okay. Anyway. Okay, so exports global linear search. I'm looking for every single instance of a particular value that I'm trying to find. All right, so let index is equal that, okay? And we are saying that it's let because it's something that can change rather than a const, which is something that won't. I'm just gonna write the same thing again, same as above. You're missing a space between the semicolon and the next thing. Or let I equal 0, I is less than that, I plus plus. If the thing that you're looking for is equal to the element at that particular index in the array, push the index into index and return indexes. Other than that, this looks pretty good. The only thing here is just a very small, syntactical thing. Just make sure that you have a space right here. And I have time for one more. Does anybody else want me to review their code? Oh, so I'm just going to choose someone. All right, Kenesha, I'm going to grab your code. Let's do a different challenge so that we're, I don't have it. Let's do 99 bottles in Python. We're going to go over to pull requests, and I'm looking for Kenesha's code. Is it here? Is this you? I can't see your right hand if you're doing anything with your right hand.
It's a KSO solution.
This one? All right, I'm just going to click this
I think
one.
it's that one.
Sorry if it's
I
not.
had some issues with down or pulling it to the. I'm not sure what got in there.
Okay, we'll find out. All right, so we got a lot of stuff here. All right, so 99 bottles, we start at 99, we go down to 2, and then it becomes like singular version instead of plural version. All right, so we got function, bottle song, original bottle count. So I'm personally a fan of doing full variable names. I know some people disagree with that, but I'd rather start with full variable names and then go into like shortened versions if I don't need to. So let's do original bottle. Start a review there. All right, so const bottle start. I'm not sure why we have this. Const original bottle start count equals orig bottle count. I'm gonna see where else you're using it on here so I can see if I can understand. Oh, I see what you mean. This one I'm not a big fan of. So what's happening here is once we get down to the very bottom, we're gonna say like, go buy some more 99 bottles again, because that's something that's not going to change. Like if I give you 5, it says go to the store, buy some more. It's 5 bottles of beer on the wall. Although I understand, I can go either way on this one. This one's just more of like an implementation of the algorithm here, because if you start the bottle song at 5, then you want 5 to start right over here. Otherwise, you can just hard code this to 99. But either way, I'm okay with it. All right, so while original bottle count is less than 2, how do I feel about this? I'm just gonna say this is fine. I might go with while original bottle count is greater than 2. I add spaces in between everything is what's going on. Console log, I take the original bottle count, which I'm passing in. So let's say that's 5 bottles of beer on the wall, and then we interpolate again, 5 bottles of beer, take one down, pass it around, -1 bottles of beer on the wall, and then you do minus minus. Okay. And then once you get down to 2, then you take care of all this. Bottle, so you're hard coding, which is fine. And go to the store, buy some more, that's fine. Let's jump down to the bottle song over here. It's more or less the same thing. While the original bottle count is greater than 2, printf, this is fine. One thing I might say is you might want to look into multi-line strings in Python. And I'm just going to look for a resource for you. So I'm going to say multi-line string Python. Let's see this first thing that shows up. Yep, it's right over here. So I'm just going to grab this resource, pass it over to you. All right, it's 8:50. I've been talking for a little bit. Let's take 10 minutes. We're going to come back. We're going to go over Git and GitHub, pseudocode, terminal commands, and test-driven development. So take 10. We'll be back at 9 a.m. Okay, so what we're going to cover for the next hour, let's do a little bit about test-driven development, and we're going to do a problem using test-driven development and unit test inside of Python. So test-driven development is also known as TDD. It's an acronym, and it's the process where you write the tests and what you want your code to do prior to actually writing the code. It's a fairly common practice inside of agile software development. And it'll really lead you to better software for a few reasons. The two that are most prominent, number one, as a developer, you're forced to think about what your program is going to do prior to you actually starting to write it. So if you were to be given like a very large problem and you have nowhere to start by writing tests, figuring out like what's each step that I need to be able to do with this particular bit of code. And then number two, once you write the tests that are good, you can change the code however you want. But as long as the output is the same, like as long as the test pass, you know that the code, anything that you've changed underneath the hood doesn't alter the function of the actual, the function of what you want your code to do. So each language has its own testing framework, and you're probably going to be required as developers to write something called write-in unit tests. There are different tests. There's integration tests, there's end-to-end testing, but your job is to write unit tests. And unit tests are to test one individual unit outside, like independent of like the entire like code base. So right now it's really easy because I'm just writing like small individual tests for small individual files. But once like those files start talking to each other, like that's where it gets a little bit more difficult. So we're going to be writing unit tests, meaning that every bit of code that we write must have tests associated with it. Python ships out with unit test, which is built into like the Python library. And we're going to take an example today. Everything I'm saying, in case that you're like, I'm not following fast enough, is all written in today's curriculum. So I'm just taking it directly from there. There is a very popular coding program called FizzBuzz. And according to Google, I'm not sure how accurate this is. Let me get the exact number. FizzBuzz prompt. C2Wiki. It helps filter out, quote, 99.5% of programming job candidates. I personally can't believe that to be true, but at the same time, I have also watched, quote unquote, senior engineers fail the FizzBuzz challenge, which means I was like, I'm not sure what you were doing at your last job, but this is fairly basic stuff. But in the case that you don't know where to begin, that's where we're going to be starting today. So the prompt reads, write a program that returns the numbers from 1 to 100, but for multiples of 3, return fizz instead of the number. And for multiples of 5, return buzz. And for the numbers that are multiples of 3 and 5, return fizzbuzz. All right, so we're going to go over some terminal commands at the same time. And I probably won't call on people just for the sake of time, just so we can keep things moving. I'm here at my terminal inside of VS Code. So VS Code is a IDE. It's an integrated development environment. And it's a place for me to both write, read, and execute code and see it work. So I'm here. It looks like I'm at the root of my particular user. I'm going to go into the desktop, and the way that I change where I'm at is the Unix command cd. CD stands for change directory. Is the size good on this, folks? Yes, okay. I'm going to cd. I'm going to first list out where I'm at. List out everything that's inside of this folder. Inside of there looks like there is a desktop right there. So I'm going to cd into my desktop. I'm going to clear the screen real quick. I'm going to list everything out again. So I've got 3 folders. And I'm going to create a new folder called test-driven development. I'm going to create 2 files. I'm going to create a file for the FizzBuzz and the FizzBuzz test file. First things first, I want to first make a directory. And that's going to be the mkdir command. And this stands for make directory. I'm going to call it TDD. And if I list out everything again, using the ls command, you'll notice that before I only had Code Platoon, Curriculum, and Personal. Now I have an extra folder, TDD. That happened as a result of this right over here. I could do the exact same thing by right-clicking on the desktop, creating a new folder, and creating TDD, but I'm not always going to have a GUI, which stands for Graphical User Interface. I might need to actually create everything through here. So I'm going to cd, change directory. I'm currently in the desktop. I'm going to change into the TDD folder, list out everything. There's nothing in there because it's an empty folder. And I want to open that folder within this entire window. So I could do code space dot like this, but this code space dot will actually open an entirely new VS Code window, like separate from the one that you all are seeing right now. So I'm going to do code -r space dot. The -r means that I'm going to open up everything here in this current window. So when I open it up again, do I want to save the changes? No, it's fine. I'll get rid of it. So it refreshes the screen, and you'll notice that I'm inside, right over here, the TDD file folder. When I open up the terminal by running terminal, new terminal, or doing command and then the backtick button on Macs, you'll see that I have two ways of creating files. Sure, go ahead. You can do fizzbuzz.py. That's okay. Or you could also just do touch fizzbuzzspec.py, and then it'll also show up right over there. Python is not installed. I disagree with you. Anyway, but actually, real cool thing, I can, how do I delete these? I don't know. I could right click. I'm just going to do RM for remove fizzbuzz, and I'm just going to do a star. What you'll notice here is inside of TDD, the folder, there are two files that start with the name fizzbuzz. When I do RM fizzbuzz with a star on it, it removes all of it. And you'll notice that these two, though they were open, now it says deleted, and they disappeared from this left sidebar. If I list out everything, which is the true way to tell if something is done, you'll notice that when I hit LS and enter, everything is gone at this particular point. So I'm just going to recreate these two files. So I'm going to touch two files at the same time, fizzbuzz.py and fizzbuzzspec.py. So touch is basically, this is how I create a new file. These two things show up on the left-hand side here. I've got them open right now. Let me grab the prompt again. Comment it out. The way that I commented out super fast was I just pressed Command A for select all, and then Command / to comment everything out. / and backslash. The difference is that if you think of a human being standing straight up this way, if you're leaning backwards, that is the backslash, that is the one above the return key. And if I am a human being standing straight upwards and I'm leaning forward, that is the / to the left of the shift key underneath the return key on the right side. All right, so let's start writing some unit tests. So fizzbuzz.py is where I'm going to write the actual code, and fizzbuzzspec, also known as like fizzbuzz test. Spec is another word for test. Is where I'm going to write all the code for the testing. And I realized there's a typo. Well, two ways I can approach this. I have fizzbuzz with only one Z at the end. I can right-click it here and then rename. And again, all these tools are built into VS Code. That's cool. Like you can totally use those. I use them all the time. But again, I've got a job, and we're training you to get the job. So it's always better to like learn how to do things from the command line rather than use all the built-ins. So here, if I list out everything, you'll see that I have fizzbuzz spelled correctly and fizzbuzz is spelled incorrectly. What I could do is that I can either remove this file and re-add it, or there's another command that I can use called MV. MV stands for move. So I'm going to move fizzbuzz spec, and I've noticed that when I start typing, I'm actually not typing the full thing. I'm going to type F and press tab. It's going to autofill as much as it can, and you'll notice that it doesn't know where to go at this particular point, because once I get to fizzbuzz without the double Z, it could go either in this direction with this particular file name, or in this direction without, like with the spec file. So what I'm going to do is I'm just going to do the next character, which is an underscore, and press tab, and it'll autocomplete again. So I'm going to move fizzbuzzspec.py to fizzbuzzspec.py. And it looks like this was deleted. That's fine, but I have this one over here. I'd like to see you lose the name to rename a file. If you use the command like that to rename a file, will VS Code see that and refactor, or will it break references to that file? It will break references to that file. All right, so I've got two files here. I've got my fizzbuzz and my fizzbuzz spec, and we're using test-driven development to try to write this. I'm just going to copy and paste this directly from the curriculum. Let's go over this line by line. On line number 1, there is a library built into Python called unit test, and inside of pretty much every language except for Ruby, you have to be explicit with what you want to import from your libraries on your computer into this particular file. So on line 1, I am importing unit test, saying that it exists on your computer, but I want it inside of this particular file. And you'll notice that I'm using unit test right there on line 4. Line 2, from FizzBuzz, this is the name of the file, import FizzBuzz, which is going to be the name of the method. We haven't written this yet, but just to make sure, we'll just say FizzBuzz method. So from FizzBuzz file, and this is all relative. So I'm inside of FizzBuzz spec.py. In the same folder, in the same level, there is a file called fizzbuzz.py. So it's saying from this fizzbuzz.py file, import the fizzbuzz method, which doesn't exist right now, but it will very soon. And this is the way that we set up unit tests. And then your tests are going to go right over here. So based on this, what do we know? I'm going to put this at the bottom so that we're not jumping back and forth everywhere. Write a program that returns the numbers 1 to 100. For multiples of 3, return fizz, return buzz instead of multiples of 5, and numbers that are which both multiples of 3 and 5 return fizzbuzz. So it looks like there's a few things. I need to return the numbers from 1 to 100. There's probably a good data structure for me to use in that sense. It's probably going to be a list. So maybe that'll be my first test. Write a test that says that fizzbuzz method returns a list. I'm going to write 3 tests, and I don't want to copy stuff over and over again. So this is something that this VS Code gives to me for free. Put your cursor on the line anywhere. Don't highlight anything. Command or Control C, depending on if you're on Windows or Mac. Control V copies the whole line and puts it right underneath. So write a test that says fizzbuzz returns a list of 100 elements because we're returning the numbers from 1 to 100. And then finally, we can write a test that returns a list, but it's actually going to be the 1, 2, fizz, 4, buzz, like that whole thing. So I'm just going to grab this whole thing and put it right there. Again, all this is in the curriculum for today. Let's start with the first one. It says we're going to write a test that says fizzbuzz method returns a list. First things first, I'm going to write a method called def test returns a list. Whenever you're writing unit tests, it must start with the word test, otherwise it does not read. So I'm just going to say, I'm going to write myself a little doc string, kind of like this on line number 5. It's going to say, when you call fizzbuzz method, you should get a list back. I'm going to write the test first, so it's going to be self.assert equal type fizzbuzz method is going to be a list. That's this first test right over here. You have changed my audio device. Hold on one second. Let me change my audio device back. HD Pro webcam. Speaker has changed. I guess we'll see how this goes. Okay, so I wrote my first test. This test says it returns a list, and this is a little bit of information for the next person that's reading your code. When you call fizzbuzz method, you should get a list back. So I'm basically asserting that these two things inside of here are equal. It's going to be a list, and when I call type of fizzbuzz method, it's going to return me a list. The type method is actually pretty interesting. I go inside of my Python shell by just typing in Python from the command line. Now, if I just do type of 1, I'll get a class called int. If I do a class of a as a string, I get a string. If I do a type class of an empty list, it's going to be a list. That's what we're trying to test here. The type when I call fizzbuzz method, like what's the return, it's going to be a list. And then we'll write these other 2 tests really quick. Returns a list, and I'm just going to write this again. And I'm going to change all of these up here. So I'm going to get rid of this, these two. I noticed that line 12 and line 16 are actually the exact same, and I want to write different doc strings inside of line 12 and 16, but I don't want to highlight it twice. So the way I'm going to do it is once I highlight one particular thing that's also in other places, I can write Command D, and now I have multiple cursors, so I don't have to type in things twice. So I'm just going to say, when you call FizzBuzz method, you should get a list of 100 elements. And then over here, when you cut FizzBuzz method, you should get the correct list of 100 elements. Here, what I'm going to do is I'm going to say, like, when I call the FizzBuzz method, you should get a list of 100 elements. I'm going to change this of 100 elements. List returns the correct list. So I've got 3 tests here. They're all written out in unit test format. I've got a method called returns a list that when I run this particular bit of code, these two are equal. The type of FizzBuzz method, the return value is going to be a list. This one is going to be a little bit different. If I do len of FizzBuzz method, it should be 100. Let's test that over here. Let's say I have an element of 1, 2, 3, 4, 5, a list of 1, 2, 3, 4, 5, and I do a equals 1, 2, 3, 4, 5. If I do len of a, that's going to give me 5. And that's the same thing I'm testing right over here. I'm trying to find the length of the return value of FizzBuzz here, and that should be 100. And then finally, I'm just going to say that when I actually run this method, I'm going to say that I expect to get this giant ugly thing back. So expected output is equal to this whole thing. I'm going to say that when I call FizzBuzz method, it should be equal to the expected output. Now what I've done here is I've given myself a roadmap. Let me bring this down a little bit. I've given myself a roadmap. Regardless of whatever code I write inside of FizzBuzz, which currently is nothing. Let me split right here. I have all the tests that I'm ever going to need. So FizzBuzz has, a list of stuff here. It has a list of 100 elements, and those 100 elements should read exactly like this. So I can write whatever I want in here, but now I know this is my end destination. This is where I'm going to end up. So now, if I were to run Python fizzbuzz spec.py, cannot import fizzbuzz method from fizzbuzz, this is where it starts blowing up. I wrote the tests, I have no code, and this is where we're going to start. So first things first, we're going to try to get it to return a list. Def fizzbuzz method. We're just going to write pass. Pass is just another way to say, like, don't blow up. So when I run fizzbuzz spec.py and I run that, I get 3 tests and 2 failures and 1 error, and everything is ugly and it's not really working the way that I want to. And there's no colors. I like to have colors. So what I'm going to do is I'm going to run pip install green, which installs a library called green inside of my machine. I've already done this one last night. So once you run through that, you can run, instead of running Python fizzbuzz spec.py, you can run green fizzbuzz spec.py. Cool. It's a little bit nicer. There's I get colors instead of just black and white, but it's a little bit easier to read. Right now, it says pass, and I just want to make this first test pass. I'm going to go what's called red-green refactor. Red meaning I'm going to watch it blow up, turn red. Green, I'm going to make it pass, and then refactor means I'm going to make it better. So if I look at this first test, it says when I call fizzbuzz method, you should get a list back. Right now, it's just saying pass. So if I just do return empty list, and I run the tests one more time, let me clear the screen by typing in clear. You'll notice that something changed right there. I got a green dot instead of a red F, and it says that I passed 1 test, but I failed 2. Cool. So I passed this first test, and then right over here it says, when you call the fizzbuzz method, you should get a list of 100 elements. All right. So what if I just do A times 100? Will that pass the test? Technically, yeah. So now I have 1 failure and 2 passes. So I passed the first 2 things. I have it's a list that's returned. It's a list of 100 elements long. And now we're actually going to tackle the entire big, the big algorithm itself. The way that I like to approach this is I like to write pseudocode. What pseudocode is that the way that I figure things is, if the more time that I spend prepping my code and the less time I will spend writing it. So I like to write very, very detailed pseudocode and not actually jump into the actual code until I'm fully ready to do so. So it says that write a program that returns a list from numbers 1 to 100, but for multiples of 3, return fizz, multiples of 5, return buzz, multiples of 3 and 5, return fizz buzz. So that we know that we're going to have an output that's going to be a list, and we know we're going to need to start from 100 and start at 1 and go to 100. So the way that I'm going to do this is I'm going to say, I'm just going to write in English. Write a method called fizzbuzz method that takes in no arguments. Based on my prompt right up here, it doesn't look like I need to actually write any arguments. Okay. Number 2, create an output variable and set it equal to that. What you'll notice is I'm also going to be capitalizing all the things that are going to be variable names or any sort of like code things. So create an output variable and set it equal to an empty array. I know I'm going to need to return that, so somewhere down over here, X, I'm going to return output. All right, so I know I need to, I need to do something weird where I need to start with 1 and then go to 100. So I'm not sure how to do that. I'm going to stop my sharing. I am going to open a new window. I'm going to share that window. All right, how to print numbers 1 through 100 Python. Automatically fills out for me. I just want to print out the numbers to begin with. And it says, okay, this is the first thing that shows up, Stack Overflow. So Stack Overflow is a website that people use to basically post their coding questions on. And then it's an online forum so other people could come back to it as well. This was asked 6 years, 3 months ago. And the way that we read this is that we start off on the top. This is where the question actually is. And at the bottom here, these are where the answers are. These little numbers here are upvotes and downvotes. So 21 other people also had this particular question. So I just kind of go straight down to the answers. The one with the most numbers generally has a check mark next to it. This one doesn't have it on there, but the check mark is the one that the author of the question agrees is the right thing. So let's just do that again. Python print 1 to 100. Looks like there is using while loop. Sure, why not? It looks like there's another Stack Overflow example right over here. Nobody agreed. There's no green check mark. But generally speaking, the first answer underneath the answers portion is going to have a green check mark, and the number is how many people upvoted and said this is the right thing. So it looks like there is a range function that's going to be useful for me. So if I want to print out the numbers 0 through 100, but not including 100, it defaults to start at 0 and steps by 1. Let's just grab this bit of code here and run it ourselves. So I'm going to run Python. I'm inside of my shell now, and I'm just going to write that. All right, so I just copied and pasted this particular bit of code. For number in range of 100, print the number. So it looks like it's starting at 0, and it goes all the way to 99.
I think you have to switch your window.
Oh, whoops, yep, you are correct. All right, so I've copied and pasted this code. And I have for number in range 100, print the number. It starts at 0, and it's going all the way to 99. That's not what I want. I want it to start at 1. I want it to go all the way to 100. So let's just tackle that bit first. Oops. All right. So I've changed a little bit. It looks like it's where'd it go? Starts at 0, and then it goes all the way to 100. So it looks like the range, the upper limit needs to be exactly like 1 above where you want to end up. And I want to start at 1. I don't want to start at 0. It's the same thing here. Let's try this again. For number in range, we're going to start at 1, go to 101. Go again. We see that we ended up at 0 and that we started off with 1. All right, that looks like it's good. So number 3 here, we're going to create a loop that starts at 1 and ends at 101. Keep track of the number you're on by saving it to num. We'll call it number. Why not? All right. 4. And then we just kind of take these rules here. For multiples of 3, if num is evenly divisible by 3, replace it with fizz, append fizz to output. If same thing here, I don't want to keep copying and typing things over and over again, so I'm just going to copy line 4 because it's more or less the same. Put your cursor anywhere on line number 9 for step number 4. I'm going to do it twice more. Command C, Command V. If it's evenly divisible by 5, append buzz to output. If it's evenly divisible by 3 and 5, append fizz buzz to output. And then 4, 5, 6, 7, else append num to output. And then it looks like here I'm just going to return output. My idea here is that I have the steps that are written in such detail that it's super easy to translate everything into code at this particular point. I mean, look at it. All right, so let's just go line by line. Write a method that calls fizzbuzz method and takes in no arguments. Done. We've already done that right over here. Number 2, create an output variable and set it equal to an empty array. Done. Create a loop that starts at 1 and ends at 101. Keep track of your number, of the number you're on by saving it to number, and I'm capitalizing all of the variable names I'm going to use. We just found something that did that for us, so looks like I'm just going to grab this here and figure out what to do next. For number in range 1, 101, and we're keeping track of the number we're on by saving it to number. If number is evenly divisible by 3, append fizz to the output. All right, so if number mod 3 is equal to 0, I'm going to do output.append fizz. All right, we're on line number 5 now. If it's evenly divisible by 5, add buzz. If it's evenly divisible by 3 and 5, append fizz buzz to the output. I'm going to copy this because it's more or less the same. All right, so if it's evenly divisible by 5, append buzz. If it's by 3 and number is evenly divisible by 5, append fizzbuzz. Otherwise, otherwise append num to output. Else output.append number. And then at the very end, I'm just going to return output. There's a few syntax errors. I'm just going to do elif, and change all of these to strings. It looks like I need to do this for all 3 of these, so I don't want to, go over here and press one button and then another button. So the way I'm going to do this is that VS Code actually allows you to highlight the whole string and then just put things on the outside. But even further, I'm going to have multiple cursors by double-clicking on fizz, holding the command key, double-clicking on buzz, holding the command key, double-click on fizz buzz, and I could do all 3 at once.
Hey, John, I think I see an issue with this, the if else.
Tell me a little bit about what error you see.
Well, you're going to end up with more than 100 items on the list. For example, at 15, instead of appending just fizz buzz, it's going to append fizz, it's going to append buzz, and then it's going to append fizz buzz. So every multiple of 15, you'll get 3 items appended instead of 1 item appended.
Well, that's a good thing. That's a good thing why we wrote tests. I mean, so we've got the test right here. It should return a list. The list should only be 100 things, and the list should read exactly like this. Let's run the test and see what happens. I think you're right. Let me clear the screen. I'm going to run green fizzbuzz spec.py. All right, I got 2 passes and 1 failure, and it looks like the first differing element is number 14. I got fizz instead of fizzbuzz. Let me take a look. So it said, man, that's not right. So let's go back over here and see what's wrong. So once we get to number 15, I see what's happening here. So once we reach number 15, 15 on line number 6 is evenly divisible by 3, so it appends fizz to the output list. And then it actually skips over the rest of it. So you're not appending 3 things. You'll notice that the other 2 tests did pass, right? Because that is, we said it's a list, it's going to be 100 elements long. Otherwise, it would be much longer at this particular point.
You're right. It's an else if instead of else. Yeah.
Yep. So it looks like we probably want to put the most restrictive thing at the very top and the least restrictive thing at the bottom, because 15 is evenly divisible by 3. It's also evenly divisible by 5, but it doesn't hit this particular bit of code, lines 10 and 11. It actually just dies off right over here. Like it executes here and then it moves away. So we want to put our most restrictive thing at the very top. And if something is evenly divisible by 3 and 5, it's evenly divisible by 15. Just going to take this here, alter a few things, and I'm going to change this to buzz, just fizz. And I think that's about it. Let's test this code. Now we have 3 passes. Again, the more time that you spend writing this code over here and the more detail that you put into it, you can kind of see that I can translate this into Python, I can translate this into Ruby or Java or anything. I have all of the things that I need right over here. These are the instructions that I need. I just need to execute it and actually write syntax here. We're going to do one more example, and then I'm going to leave you. Let's do something a little bit more difficult. I'm going to list out everything. Let's create 2 new files. So clear at the bottom, punch, Roman numerals.py. Is it okay to put pseudocode in the test file? You can if you want to. Yeah, you can if you want to. I probably wouldn't. You can put pseudocode in the test file. I wouldn't commit it. Like I wouldn't say like this is where, like I wouldn't say like this is good enough to be pushed into like production. Let's do one more. All right, 27 minutes. Can I do it? I think so. Let us grab Roman numerals for Lima Platoon. We're going to run through all of our Git commands as well. I know that everyone did this already, so it should be more or less a review. So Git and GitHub are 2 separate things. Git is the version control software. GitHub is just the online website that you host all your Git repositories on. It just takes advantage of the name Git in their company name. And it was also bought out by Microsoft last year for like a bunch of billions of dollars. It's like a ridiculous amount of money. But the first thing I'm going to do is I'm going to make a fork of this particular repo. What this is doing is it's making a photocopy away from Lima Platoon Roman numerals, which is where, like, think of like George Lucas's original script is right over here. You don't want to alter George Lucas's script. You want to make a photocopy, make your own edits, and then say like, hey, George Lucas, is this good enough to put back into your original one here? So I'm going to hit the fork button. I've already forked over this. I'm just going to, sorry, let me delete this. Okay, so I deleted it. Let me refresh here. All right, so I've got Lima Platoon Roman numerals. I'm gonna make a fork real quick. I'm gonna fork it to my account, my personal account. And there's this cute little graphic that's going to come up of something making a photocopy. And what this is doing is it's saying, I don't want to alter the original Lima Platoon Roman numerals because that's George Lucas's next script. Instead, I want to make a photocopy. Now it lives at J Young 217 Roman numerals. It's not pointing at the original one. The next step I'm going to take is I'm going to clone it. Cloning is another fancy word for download. So I'm going to go here. I'm going to cd out one level. I'm going to change away from the TDD folder back into the desktop. By cd space dot dot, that'll take me out one level.
You need to change the screen.
Oh shoot! Yeah. This is the fun part about having an enormous monitor that will not fit on anybody's laptop screen. All right, so I'm going to clone it down by doing git clone, and I'm going to paste that link that I had. Every single git command is prepended with git. If you're running a git command, it's going to have git right in the front, unless you set up an alias. So git clone, jyoung217, Roman numerals.git. What this is doing is it's reaching out to GitHub. It's saying, I want to download all the contents from here onto my machine. When I list out all my contents again, you'll see that Roman numerals is actually cloned all the way down here. I'm going to cd into Roman numerals. And you have two choices. You can do either code space dot. This will open it up in a brand new window. But since you're all looking at the same window as me right now, and I don't want to stop sharing and reshare again, code space dash R. It'll refresh the entire window with the with this particular folder loaded up. So I'm going to take a look at Python, Roman numerals, and Roman numerals spec. We're going to write everything out in TDD first, and it's going to be more or less a copy and paste of what we had before. Let me just grab that code from before, and we're just going to alter a few things. I'm just going to grab FizzBuzz spec and drag it in here. I'm going to grab all the contents here, copy paste, put it inside of Roman numeral spec. More or less the same. Import unit test, but instead of FizzBuzz, I'm going to import Roman numerals. I'm going to import to Roman. All right, I'm going to call this class Roman numerals test case, tests for Roman numerals.py. And then I'm just going to have a bunch of test cases that I'm actually just going to write one giant test case. Test translates Arabic numbers into Roman numerals. When you call Roman numerals, you should get correct Roman numeral. All right, so this one's actually going to be a lot easier than the previous one because a bunch of it is written right over here. So I'm actually, it looks like I want to put the one over here on the left side of the equal sign and the Roman numeral itself on the right-hand side of the comma, sorry. So it looks like all of this is here. They more or less look the same. So I'm actually going to do a little bit of fanciness here. I'm just going to grab all of this and I'm going to hold down Command Control. I'm going to just bring it over here. Command Control up and down will bring down entire lines at a particular time. And because I don't want to type the same thing over and over again because I am lazy, I notice that there are 3 print statements in a row. Double click, Command D, now I have 3 things. So I'm just going to do self.assert equal. I'm going to call to Roman, and then I can just do comma, and I'm done. I probably should do some more. So I will do 2 more. I heard a question. What's up? No? Okay, that's fine. So it looks like 944 gives me CMX LIV, and then I will have 44 as XLIV, and let's do 150 as CL. right, so I think I can get rid of all this, and it looks like I've written my specs at this particular point. I more or less copied and pasted, but now that I've got a solid place to go, I know that I can actually just write the code and hopefully it'll execute to give me a bunch of green tests. With that out of the way, let's write some pseudocode for 2 Roman. So if I gave you the number, I'm doing that time, I'm doing well. Okay. If I gave you the number 8, we know that's VIII. And the question is, like, how did our brains do that? Because we know that computers are a lot faster than we are. Like, they compute stuff at a much faster rate than we do. However, they're really, really dumb. Like, they don't know what they're doing, and they only execute what we tell it to execute until we get to AI and then we're all dead. But we have the number 8 right over here, and we immediately said it was VIII. What are the steps that your brain took to get there? We know that this more or less, and this comes from the curriculum, this more or less says that, like, this is the translation from Arabic, which is the numbers on the right, to Roman, which is on the left. And then we know that M is probably too big. Is import unit test for the assert equals? Yes, it is. This over here, the import unit test is found on line 4. This is where we're using it. And self.assert equal is basically saying, given 2 arguments, the first one is to the left of the comma, and the right side of the comma, these 2 should be the same thing. So when I call 2 Roman of 1, I should get a string of I. When I call 2 Roman of 44, I should get a string of XLIV. Coming back over here, I know that 8 translates into VIII because that this is too big to go into it, this is too big to go into it, and the smallest denomination that comes is actually 5. So I know that 5 divides into 8 and doesn't give me a 0. Let me write my pseudocode here. 1, write a method, 2 Roman, that takes in a num as the argument. I know that number 2, create an output string, because we're going to be like writing a string and we're going to be adding onto it. And somewhere all the way down here on line at step number X, I'm going to return the output string. 18 minutes, I'm doing okay on time. Now, we've got this over here. And the way that I think about this is, all right, so 1,000's too big to divide into 8. But 5 is not too big to divide into 8, because 8 divided by 5 gives me 1. But 8 divided by 1,000 gives me 0. So the way I'm thinking about this is, the moment that I can divide something into this original number and get something that's greater than 1, that's the letter that I need to keep track of. I need to move that in. At that point, I can do an 8 minus 5, and I get 3. But at this point, I've already had, and then we have output is equal to V. And I basically repeat the process again. 1,000's too big to divide into 3. 5's too big to divide into 3, but 1 is not too big to divide into 3. So at that point, I know that 1 goes into 3 3 times. So I just take 3 i's, put it in, and then I do it again. Minus 3 gives me 0, and then the output is actually just going to be VII. So my thought process here is I'm going to create an output string. I probably need to create a Roman to Arabic dictionary and set it equal to this giant thing. I know this doesn't cover every single case, but we are just worried about numbers somewhere underneath 1,000 for right now. All right. My next one is basically like iterate over the dictionary, save the, and have access to the Roman numeral and the Arabic number. And then this is where a bunch of the if statements come in. If num divided by Arabic number is greater than or equal to 0, then we get that number and subtract I guess is this useful? Do you want me to continue doing this, or do you want me to do something different?
The other way you can do it is you can take the floor of it and use it doing dividing.
I could do that, yeah. All right, so we could get the floor of it. Yeah, that's a separate way to go about it. Okay, so we're gonna get that number and save it as evenly divisible times. All right. Next, what we're going to do is we're going to append Roman numeral to output evenly divisible times. Then you're going to take the number, subtract number. It's actually going to be like number minus Arabic number times evenly divisible times. Could take modulo, that's fine. And then you're basically going to repeat this until you go through the entire dictionary. The way this works is because we're starting at the very top with the highest number first. We're actually, if we do like in our spec file, we have 944. We're actually going to start here. This is too big, so 900 goes into it, and then we just keep going down until we hit the next number, which is 40, and then we get them here, and that's 4. This is why that works in that particular way. I think these are all the steps that I'm going to need for this particular algorithm.
On line 23,
Yep.
do we want to change the 0 to a 1? Because even, let's say we had the number 4 and we're trying to divide it by 1,000, it would be 0.004, which is still greater than 0.
I know. Let's take a look. So let's go into Python. Let's do wait, say what you were saying one more time.
As an example, picking the number 4 or the number 8, and we mentally went through and divided by 1,000, we knew it couldn't fit. So if we did that as our example, 4 over 1,000, that 0.004 is greater than 0. So we could either set it to greater than or equal to 1,
Okay.
or if we could do if num // or the basically getting just the quotient portion, if
Yep.
that's greater than 0.
Cool. Let's add that in there.
That's what I was talking about with taking the floor.
Yep. All right, so we've got the 2 Roman here. Let's just kind of go step by step over here. So we're going to write a method that says 2 Roman, that takes in num as an argument. We are going to have output as a string. We know somewhere at the bottom we're going to return output. We're going to create a Roman to Arabic dictionary and set it to this. So it looks like we've got it already, which is nice. I'm going to highlight all of this, Command / to get rid of the comments, and then recomment it again. All right. And then next it says we're going to iterate over the dictionary and have access to the Roman numeral and the Arabic number. All right, so I don't really know how to do that. So let's stop this share here, open up a new window, share this particular window, and let's take a look here. How to iterate over dictionary Python. Looks like there's real Python, Stack Overflow. I'm just going to grab this one because it's the most recent. It's the first one that shows up. All right, I'm just going to look for it. Few words on dictionaries. This is the problem with like these very large tutorials, is that it takes forever to get here. Oh, there it is. For key in dict, print key. So like it looks like you have a dictionary right over here. Color blue, fruit, apple, pet, dog. And I want to get just the keys. So I've got color, fruit, and pet. So if I can iterate over each one of these and get the key. So I got color, fruit, and pet. So I'm just going to grab this whole thing for right now. I'm going to put it inside of my code, which I need to stop sharing there and reshare here. Some version of this. So for, and I want to be super like specific about my variable names. So for Roman numeral in Roman to Arabic. So it looks like I have access to the Roman numeral, but I don't have access to the actual Arabic number. So I'll just say Arabic number is equal to Roman to Arabic at Roman numeral. So when I'm iterating over this for the first time, Roman numeral is saved as M, and then I need access to this particular thing here. So I'm going to say Arabic number is equal to the dictionary at index at this particular key of M. All right, so now we have all of this stuff over here. I'm just going to copy it and paste it over here. All right, if num, oh, this is nice. If num mod Arabic number is greater than 0, then we're going to get the number, which we have as Arabic number, and save it as evenly divisible times. Let's say evenly divisible times is equal to, and we're going to change this to evenly divisible times. So I've got the Arabic number. I'm just going to run the math each time. So if I have like the number 4, I'm going to do 4 with floor division of 1,000, because that's the first time through here. If it's greater than 0, then I want to append Roman numeral to output evenly divisible times. So I want to say that if I have A as a string, and I want to append 4 A's, A times 4. It doesn't work. How do I push? Oh, it's plus equals, right? All right, so it looks like I've got the letter A, I've got, sorry, the variable A here, and I want to repeat the letter A 4 times through here. So at this point, what I'm going to do is I'm going to do if the number with floor division by the Arabic number is greater than 0, get that number, save it as evenly divisible times. We did that already. Append Roman numeral to output that number of times. So output plus equals that number, evenly number of times, Roman numeral times evenly divisible times. And then we're going to subtract it. So I'm just going to grab this whole thing, put it right there, say number num minus equal Arabic number times evenly. And I think that should do it for us. Let's see if this works. We've got our spec file, so we can feel confident that no matter what we type in here, as long as these tests pass, we're good to go. So let's exit, clear the screen, list everything out. I'm going to cd into Python, change directory from where I'm at into the Python. You'll notice that it appends right over here. List out everything again. I'm going to run green Roman numerals _ tab spec, and everything does pass at this particular point. I've got 5 minutes, so I am ignoring all questions, sorry. All right, at this particular point, I need to push all the code that I wrote on my machine up to GitHub. The way that I'm gonna do that is I'm gonna cd out all the way out to Roman numerals, and I'm going to take a look at what I did. So every single git command starts with git. So I'm gonna run git status. When I run git status over here, it shows me that I've modified 2 things, meaning that from the time that I cloned it down or downloaded it from the internet, I changed 2 files, Python Roman numerals and Python Roman numerals spec. I can take a look inside of here what I changed by running git diff. And it looks like I removed that line that says write your code here, and I added all these things that are green. This is what we expect. All right, I feel comfortable with this, so I'm gonna run git status. I'm gonna git add each individual item. So I'm gonna add Roman numerals, and I'm gonna git add Roman numerals spec. When I run git status one more time, you'll notice that this turned from red to green. So I imagine this as you are giving a care package to somebody that you care about. So you've got an empty box. You can put things inside the box, you can remove things from the box, but once you're ready to put the tape on and put it like a little message over it, like the shipping label, I can run git commit. The git commit is basically the same thing as putting the tape over your box. And I want to write a descriptive message that says, finish the solution in Python. Something that you can look back at and know that this is what I actually did. These commit messages being very, very descriptive is pretty important. I'll show you what I mean in just a second. So just to run through it again, I ran git status to see what I changed. I git added, which means that I'm going to add particular things that I want to push up to the internet. Once I'm done with all the things I want to add, I'm going to run git commit -m. So I'm just saying, like, I'm good with this. I'm putting the tape over the box. I'm going to say, like, this is what I want to push up, and this is the message that's associated with that particular commit. When I run git status again, you'll notice that everything disappeared because it's part of the history now. I'm going to do git push origin master. And what you'll notice is that the git push origin master basically just means git upload. Just upload it from my machine to the actual web. And last bit, what you'll notice is if I go to my Roman numeral spec right over here, you'll see that I have the commit message, finish the solution in Python. At this point, I think I'm good to go. I want to open a pull request. So I'm going to click on pull requests, click the green button for new pull request. And then I want to basically say, I have some changes that live at J. Young's Roman numerals master branch that I want to put into Lima Platoon Roman numerals master branch. So I'm comparing the changes that I made over here to the already existing repo that lives over here. Then I click this. Keep in mind this says 14. And now there are 15 pull requests. So now this is changes that I made on my particular machine that I uploaded to GitHub that I'm comparing against Lima Platoon's master. One final thing, and then I got to run. You want to have super descriptive commit messages, because otherwise, let's say a month from now, 2 months from now, you want to go back to take a look at some of the work that you did. This is not useful. You have no idea what you did at any particular bit of time. But like, added full project, code is still shit. Like that's not useful, right? Like what? Like these are bad examples of bad commit messages. However, if you take a look at this commit message here, it's kind of like, I finished the solution in Python. You know exactly what you did at that particular point. If I did the same thing inside of JavaScript, I would write like finish the Roman numeral solution inside of JavaScript. And I know exactly what I did at that particular point. And with that, I'm going to give you all a 10-minute break. I didn't cover everything, but it's up to Tom if he wants to go over like if-else statements or just jump straight into challenges. Thanks for listening. It's been fun. I will see you all tomorrow. Bye.
Thank you,